that slide or for in the next slides we only see the character code, that is ASCII code. Okay, so each and every number or the alphabet, for example uppercase to lowercase, as well as 0 to 9, and then next there are different types of numbers. Okay, so each and everything is represented in the ASCII code. Okay, and there are 2 raised to 7 means what, 128 is their size. Okay, so character codes are mapping between numbers and the symbols which make up the particular alphabet. Yes, so numbers and the symbols of a particular alphabet is nothing but the character code. Computers are fundamentally designed to work with a numerical data. Fundamentally, we discussed in the previous that a particular computer are fundamentally work on numerical data only. All they know about a given alphabet is which symbol is assigned to each possible numbers. So according to that particular possible number, we or specific alphabet, we use the combination of that particular numbers. So when changing the font in a print program, all that really changes are the image bits or bitmaps associated with each character. Yes. So here, according to the character, we have to change the bitmap when we have to change the font of the print program. And when we changing our operating system from, suppose here the example is English to Russian, all the characters are changed. The symbol or mapping of the symbols of all the characters are changed. Hmm? So that's why in a specific PPT we see that, okay, according to that specific language, for example English to Russian, we have to change this that symbols in the character codes. Means what, we map their symbols in the character codes. That's so. Next, as per our previous discussion, 2 raised to 7, 128 characters are provided in ASCII table. Okay. ASCII means what, American Standard Code for Information Interchange. In a single byte character, there are we will stores all the information in the computer as a sequence of bytes. So 1 byte are specified for 8-bit entities. For the 8-bit entities, for example, if we refer the character capital A and small a, there is a difference of their place also, and that will be present in ASCII table in a different way because the lowercase and uppercase are different for the ASCII character. So that means the highest order bit is left as 0. Yes. All non-printable characters have either the first 3 bits as 0 or all 7 lowest bits as 1. The characters those are non-printable, their first 3 bits are 0 or the lowest 7 bits are 1. So this makes it is very easy to eliminate them before displaying chart. That's it. So although somehow ever very few programs seems to do so. Both the upper and lower case letters and the numerical digits appear sequential. Thus, we can iterate through all the letters or digits simply by looping from the value of the first symbol, say A, to the value of the last, that is lowercase a to z. So here there are the codes of that particular characters. Okay, for example, STX, SOH, start of I think the next ETX, UOT, end of terminal, BNQ, ACK, BL, PS, ST, NL, so VT. So from 65, there is a character capital uppercase A up to the 90, the next 91, 92, 93, 94, 95, 96. These are the special symbols. After that, 97 onwards up to 122. There is the lowercase letters. So friends, here if we find the value of suppose, or we have to change uppercase to lowercase. For example, here we have to take the example of a capital C to small c. So what we have to do here, we simply find the difference, and we also add something. For example, for finding the small c, for printing the lowercase letter c, here what we have to do, we perform some calculations. For example, capital C, that is 67, minus capital A, that is 65, plus small a, that is what, 97. If we have to calculate it, 67 minus 65 plus 97, we get 99. Yes, and the output is what? It's a lowercase c. So like this, we convert the characters into number of, or we have to represent the different types of characters, means what, from lowercase to uppercase as well as uppercase to lowercase, or some symbols also. Some of the combinations we also decode by using ASCII code characters, no problem. Only there is what, if the specific character does not define or not use, or that is something is not important for us at that time, that particular character consists the upper or higher case, or the highest bits of that particular character is three character is zero, or three, yes, number is zero, and a or the lowest seven bits are one. Okay, so this is very important in the ASCII. So we can convert a character C, capital C, that is uppercase to lowercase, by adding the difference. As per our previous discussion, capital C is I think 67 minus 64 plus 95, something like this. I think 97. Okay, we have to get 99. So that is what the capital C is converted into smalls. Hmm. So non-printable character codes for new line, that is 10 slash n in C language or C++, and carriage return, that is 13, are designated to eliminate the end of text line limits or lines. So like character codes, we also seen here the representation of a string. So as per our previous slides, or we every students of third year knows that what is string, because we will be use that string or the combination of that particular strings in your program, perform that perform some operation on the string. For example, string concatenation, you have to find the length of the string, as well as you combine two strings. You have to compare the strings, you have to trail the strings, find the last three characters or first three characters from the string. There are lots of operations you have to perform on the string. So friends, string are sequence of characters. Okay, so null terminated arrays. What the null terminated arrays? If we do not terminate the string slash zero, so there are lots of disadvantages are generated in our program. So here null terminated arrays, C or C++ treats strings as an array of characters. Yes, so bunch of characters or array of characters is a string in C or C++. The string ends the instant it hits the null character at last, or at the trailing bit of that specific, or trailing character of that specific string is slash zero, that is zero ASCII. Failing to end your string explicitly when a null typically extends it by a bunch of unprintable characters. So, in defining a string, enough array must be allocated to hold the largest possible string plus the null, unless you want a coverdom. Means when you define the string, or when you refer the string in your C or C++ program, at that time that particular string is always end with slash zero. That is uh, the null character. Otherwise, there are some errors are generated, or some spaces of memory are used more. That's it. The advantage of this array representation is that individual characters are accessible by index as array elements. So as per you know, array is this array, we define array for the string, and each and every location of the array, that is what the index, that is 0 to as per the user defined lower size.